All right, we're going to talk about systems of equations and their solutions and what their solutions mean. So we have these two equations here, and they're in slope-intercept form. So if you're given an equation that's like, say, in standard form, you're going to want to switch it into slope-intercept form, or you can graph it from standard form. It's whatever your preference is. So here on the first one, so this is our first one, we have 2x minus 1 equals y. So we know our y-intercept is at -1, and we're going to go up 2 over 1. Then remember, we can do negative direction, so down 2, backwards 1. Okay, and so we have our line. So I'm just going to quickly graph a line through all those points that we just put in. Okay, so we graphed our first one. And now I'm going to graph my second one. So this time our y-intercept is at +4, so 1, 2, 3, 4. Our slope is down 3, so we're going to go 1, 2, 3 over 1, 1, 2, 3 over 1. So here I have enough points that I can draw a line in, because what we're looking at is we want their point of intersection. And so we could tell that when I went down 3 over 1, this point was the first point where they intersected. So I can graph this line through here, and we know that this is their point of intersection. So this was at over 1, up 1. So this point is at 1, 1. So this is what we call a solution. And the solution is the point where these two graphs, these two lines, when I graphed them, intersected. So what this means is if I were to plug this back into both equations, so we're going to do that down here, this is saying that x equals 1 and y equals 1. So this should be true for both of these up here. So I want to know, does 1 equal 2 times 1 minus 1? So 1 equal 2 minus 1, and so 1 equals 1, so it was true. So we know that it's a point on this first line that we graphed. We want to make sure it's a point on the second line. So we're going to do the same thing here. 1 equal -3 times 1 plus 4. So does 1 equal -3 plus 4? And does 1 equal 1? Yes, it does. So since it was true for both equations, I graphed it, they intersected. It is a point on the graph. Our solution, or point of intersection, is 1, 1, and that's what we're looking for. The point that is true for both of these up here. So we also know that graphing isn't always the best way to go about things. If our graphs aren't accurate, or let's say that maybe they don't intersect at an exact coordinate point, and that we get these fraction solutions. So we can actually graph these by substitution. We can solve this by substitution instead of having to graph it. So I'm going to use the same one up here because we already know the solution is 1, 1. Okay, so I have these two functions, y equals 2x minus 1 and y equals -3x plus 4. Since this is y equals this whole thing right here. These two things are equivalent. The left side equals the right side. So -3x plus 4 is y. So if we're going to do this by substitution, we had to plug it into the other equation. We never want to plug it into the same one, or we'll always get that it's 0 equals 0. So the first equation here was y equals 2x minus 1. This also has a y, but this time y is going to equal -3x plus 4. So we can rewrite this equation, -3x plus 4 equals 2x minus 1. So we have it rewritten here like this. And so now we're going to be doing simple solving. We want to get our x's on one side of the equation and our numbers on the other. This will allow us to solve for what x equals. If we remember from up here, x should come out as 1. Okay? Since this x is negative, I'm going to go ahead and move it to the other side to make it positive. So I'm going to add 3x to both sides of our equation. Remember, what we do to one side, we have to do to the other. We want to keep them balanced. This is 0x, so since it's 0x, I'm not going to rewrite it, and we're going to bring the 4 down. 2x plus 3x is 5x minus 1, because this also gets brought down where these were combined. So since all my x's are over here, I'm going to take this 1, and I'm going to move it to the other side. When I combine these, I get 5 equals 5x. Negative 1 plus 1 is again 0, so we're not going to rewrite it. When two things are written side by side, we have to remember that this means multiplication. So to move it over, we are going to divide. 5 divided by 5 is 1, so we have 1x over here. And 5 divided by 5 is going to reduce to be 1, so 1 equals x, which is what we wanted from up there. So x equals 1. Now, you might be asking, this only gives me x. How do I get y? So if this is our x value but not our y value, we have to plug it back into one of the two equations up above. So we're going to take this x, and we know that y equals 2x minus 1, and so x now equals 1. We're going to substitute this 1 in for this x up here. So y equals 2 times 1 minus 1. So y equals 2 minus 1, or y equals 1. When I get x and y, I now have my point of intersection. Your last step is to actually write it as a coordinate point, because remember, it is a point where these two things intersect. So using substitution of these two equations, we found that the coordinate point is 1, 1, which is what we had up here. So we could either do this one by graphing or by substitution. I have another example over here that is written in standard form. I'm going to erase this so that I have more room to write over here for you guys. And this equation right here is negative 4x plus y equals 6 and negative 2x plus y equals 2. Since this is in standard form, we're just going to rewrite both of these. And I'm going to take the 4x and I'm going to add 4x on both sides. So y equals 6 plus 4x. Same thing over here. I'm going to rewrite this one. I'm going to take the 2x and I'm going to add 2x on both sides. So y equals 2 plus 2x. We can now see that we have the y equals and y equals. So I can take this and I can substitute it in here. So I have 2 plus 2x equals 6 plus 4x. And now I'm going to start solving just like we did on the last one. So this time I'm going to take this 2x and I'm going to subtract 2x on both sides. Doesn't really matter which one you pick. I know that if I subtract 2x, that 4 minus 2 is going to give me a positive solution. And that's why I chose that one. So we're going to have that 2 equals 6 plus 2x. I'm going to move my 6 to the other side. Opposite operations was positive, so I'm going to subtract. 2 minus 6 is negative 4. Again, if it's being multiplied, opposite operation, we're going to divide. So negative 4 divided by negative, negative divided by negative is going to give me a positive. So 4 divided by 2 is 2. So 2 equals x. Okay? So if we remember, once we get the x value, we have to take one of our original ones, so one of the original ones up here. We're going to substitute in our x to be able to solve for y. So we have negative 4 times x, which x is now 2, plus y equals 6. And over here I'm going to do my work of plugging it in. So negative 8 plus y equals 6. Add 8. Add 8, so y equals 14. So in this case, our solution, or our point of intersection is 2, 14. So I showed you guys how to solve graphically, and I showed you how to solve using substitution.